All right, IM3 classes. We are continuing on with properties of radicals. Today, what we're going to be doing is a process called rationalizing the denominator. To rationalize the denominator, we don't want an irrational number in the bottom of a fraction. And that's what roots give us. Radicals give us irrational numbers. So stuff that we can't represent as a whole number. I'll go over that more in class. The important thing to remember, I'm going to give a little example of what's going to happen on these. What we're going to be doing is just multiplying the top and bottom by whatever radicals in the bottom of the fraction, and that's going to rationalize it for us. Let me explain a little bit what works. So let's say we'll do square root of 5. If I were to multiply the square root of 5 times the square root of 5, all right, what happens is if I can squish those two underneath one radical. So square root of 5 times square root of 5 is square root of 5 times 5, which is square root of 25. Square root of 25 is just 5. So if we start with the square root of 5 and we multiply it times itself, right, we just end up with 5. The radicals cancel each other out. You can think of it as square root of 5 times square root of 5 is also the same thing as square root of 5 squared. So the radical is just canceling out. And we're going to use that back to rationalize this denominator, get rational number in the bottom there. And so what I'm going to do is multiply the bottom here, top and bottom, by the square root of 3n. So 5 times 3n, I can squish all that underneath one radical, right? Let me fix that before I move any further. So 5 times 3n on top. And here's the thing, just like I showed over here, when you multiply a radical times itself, the radical just cancels out. So all we're left with just 3n. I'm not going to show all the work, right? We just got to remember the fact that when you multiply a radical times itself, the roots go away. On the top, 5 times 3 is 15. So I get 15n and a radical. And then 3n on the bottom. This board is just... now it's going to be tempting to simplify this even further. So like have the n's cancel out and then 15 over 3 would be 5 over 1. It does not work that way. You cannot simplify things. You cannot simplify things since this isn't a radical. This is not. Can't simplify them. So you just leave it like that, right? If they're both in radicals, you could reduce that fraction, or if they're both were not in radicals, but since one is a radical and one is not, we can't simplify. A couple more examples. So here, I'm going to just multiply top and bottom times the square root of 5. This one's actually real simple. Here, square root of 5 times square root of 5 is just 5. 1 times the square root of 5. That's easy. Just square root of 5. We're done with that one there. Next one, you're going to multiply top and bottom by the square root of 3. Using properties of radicals, I can squish those two on top underneath one radical. So it's square root of 10 times square root of 3. Square root of 3 times square root of 3, the roots just go away. So it's just 3. Square root of 10 times square root of 3 is square root of 30 over 3. Again, does not reduce because we have one in a radical, one not in a radical. Just a couple more here. This one, we multiply top and bottom by 2x. That 7 on top is not in a radical, so I can't squish those together. So it's just going to be 7 on the outside, 2x on the inside, just like that. And then 2x, root 2x times root 2x, the roots go away. So it's just 2x on bottom like that. This one here, before I multiply, what I'm going to do is actually separate these out. So it's going to be 2y squared over root 3. And then now I'm going to multiply top and bottom by root 3. So here, this one's going to take a little extra work. Root 3 times root 3, that's easy. It's just a 3 there. I can squish the stuff up here together, so it's going to be 2. I'm going to take a little step here. I am going to expand the y squared. You might not notice this right away, but that y squared, since we have a pair of y's, I can take them out of the root, right? Using a buddy system, I can take those out of the root, and then I just have to multiply those on top. So 2 times 3 is 6 over 3. So root 6 over 3. That one took a little bit of extra work. But if you can recognize perfect squares in there, they can make some things easier. Moving on, what we're going to do is rationalize denominators by using the conjugate. The conjugate, real simple, is it's going to be on the bottom. You're going to multiply top and bottom by the same thing. So multiply top and bottom. I'm going to put this in parentheses. We'll see why in a second. All you do for the conjugate is change. If it's plus here, you change it to minus. If it's minus, you change it to plus. That's all you do. Change here, and then I'm going to do the top by the same thing, by that conjugate. So all that's changing is the sign in the middle, and then we got to multiply things through. The top is easy to multiply. So over here, you got to distribute. So 7 times 2 is 14, plus 7 times root 3 is 7 root 3. On the bottom, I'm going to do this multiplication down here because we got to remind ourselves how to multiply these. This is going to be a distribute, or split and distribute, or FOIL if you prefer. If you want to make a box like we did polynomials, that's fine. I'm just going to distribute the 2. So 2 times 2 is 4. 2 times root 3 is 2 root 3. This is a negative root 3, so negative root 3 times 2 is negative 2. You can actually do it this way. Negative 2 root 3. God. Negative 2 root 3, and then negative root 3 times root 3. So it's the negative in front here, so I got to keep track of that negative. Root 3 times root 3 is just 3. All right. What's handy here is positive root 2 root 3, negative 2 root 3. Those are just canceling each other out. So now I just have 4 minus 3, which is going to be 1. So 4 minus 3 is 1. So on the bottom is 1. And then I can actually just simplify that even more as just 14 plus 7 root 3. That is it. So that's the tough part, just multiplying it. Just remember roots multiplied times itself. You just drop the root. So let's do another example. So here, I'm going to multiply top and bottom by the conjugate. I'm actually going to let's put parentheses around there. So this one is going to be 1 minus root 3. Fix that because it's annoying. 1 minus root 3 over, on top is 1 minus root 3 as well. Distribute on the top. 8 times 1 is 8. 8 times negative root 3 is negative 8 root 3. I'm going to do the bottom off to the side because it's a little bit more work. So 1 times 1 is 1. 1 times minus negative root 3 is negative root 3. Root 3 times 1 is positive root 3. Root 3 times negative root 3 is negative 3. So here, the bottoms, so root 3, these cancel each other out. I just have 1 minus 3 left. 1 minus 3 is negative 2. I'm going to do a little extra work here. I'm going to separate this out. So it's going to be 8 over -2, minus 8 √3 over -2. I'm just, write it like that. I'm just separating this out because this does simplify. So 8 over -2 is -4, plus -8 over -2 is +4. So if the fractions simplify, you can see they both simplify. I like to split into two fractions and then reduce each individually. Let's just do one more. All right. So this, I'm going to multiply by √5 minus 2, or nope, plus 2. On top, √5 plus 2. So distribute the 13. √13 times √5 is going to be √13 times 5 plus 2 times √13. Oh, apply there. We're going to do this one down here, √5 minus 2 times √5 plus 2. √5 times √5 is 5. √5 times 2 is 2 √5. -2 √5 times, or -2 times √5 is -2 √5. And then -2 times 2 is -4. So these cancel out. I get 5 minus 4 is 1. So on the bottom, I just have 1. And then one more step to just make that easier. √13 times 5 is √65 plus 2 √13. And that's as simplified as that one gets. And it's all over 1, so we can just kind of forget about that. And that will do it for this part here. See you guys next time. Maybe.